Okay, when it comes to integration, we've talked about the fact that when we're finding the area under a curve, that frequently is allowing us to determine the area under that curve, right? So we say if we have this curve and it's doing whatever it's doing over here, and if we're able to know that function and find the area under that curve by taking the integral, that allows us to get the integral. Now, the area under a curve is a two-dimensional construct, area, we've got two dimensions, square feet or whatever. If we took a function and generated a solid by rotating it around through 360 degrees, we would then be able to have a volume, because it would be a three-dimensional object, and chapter 6, section 6.1 in particular, talks about how we can determine the volume of an object given a particular type of formula, etc., that might be there. Now, some things, you know, we already know formulas for things like cylinders, we can get formulas for volume of those kinds of things we can look up, but some functions are not that standard, and that's when we talked about area as well. I started by talking about triangles, and of course we already know the area of the triangle, but we could use the formula to get it. And then when it became a more complicated function, we were also able to use the integration approach in order to find the volume. So, one way that we could find a volume too is we could just think, if we have a particular shape, if you think about a swimming pool that looked like this and was just deep, it could just have a depth. Then you would just have that additional dimension. You would have a depth of 4 feet or whatever, you just multiply by that. But what we're going to talk about in this section is not just a three-dimensional object like that, but one that actually gets revolved around an axis. So, let me put a function up here. Let's just say that we start with the function, just to keep it simple, we will start with a function that, let's say, f of x equals x squared plus 2, and I'm going to go, so this is 1, 2 here, and I'm going to rotate this thing around the axis like this. Now if I do that, what's going to happen? Well, I'm going to see a reflection over here, but that's not all I'm going to see. It's going to be in between here. It's going to be of that shape as well. And I'll make this so that it only goes, it's only in the domain from x equals 0 to x equals 2, okay? Which should mean that this gets big a little bit faster, okay? More like this. And then up here would be the point 2, 6. Okay, so we plug that in, that's what we get. And then this would form, if you think about what that looks like, okay, it basically would look like the end of a bullet or maybe the end of a football, that kind of thing. We can determine what the volume is in there based on doing this rotation. Okay.